Do you know one simple test can separate primary, secondary, and tertiary amines within minutes? Today, I'll teach you the Hinsberg method of separation of amines in the easiest way possible. Hello students, welcome back to my channel. I'm Dr. Swati, your organic chemistry coach. So in this video, I'll be explaining about what is Hinsberg method of separation of amines and how it is useful to separate primary, secondary, and tertiary amines. Stay with me till the end of this video because this is one of the important 5 marks question in your final examination. Now let's jump into the topic. I'll be discussing about this topic under 3 headings. What is Hinsberg test and why it is important and how we can conduct this test. So this Hinsberg test is a chemical method which is used to separate and identify primary, secondary and tertiary amines. So in this, we'll be using a reagent which is known as Hinsberg reagent, which is nothing but benzenesulphonyl chloride. Now this is the structure of benzenesulphonyl chloride. It consists of benzene ring with SO2Cl group. So this SO2Cl group is known as sulphonyl chloride. When it is attached to benzene ring system, it is known as benzenesulphonyl chloride. So this benzenesulphonyl chloride is the actual chemical compound which is used in this particular Hinsberg test. So why this Hinsberg test is important? Because it helps in distinguishing amines present in the mixture. And it is also used to identify the unknown amines. Whether they are primary, secondary or tertiary, we can easily identify from the unknown mixtures. And of course, it is important for you to learn about Hinsberg test because it is a definite question in your final examination. Now let's see how we can perform this test so that we can differentiate primary, secondary, tertiary amines. Now let us consider each amine case separately. So each amine reacts with this Hinsberg reagent differently. Now let's see in case of primary amines. So here a general structure for primary amine is given. So primary amines means out of the 3 hydrogens present in ammonia, 1 hydrogen will be replaced with alkyl moiety. So this is an example for primary amine. So primary amines, when they react with benzenesulphonyl chloride in the presence of alkali, there will be first formation of N-mono substituted sulfonamide. So what is happening, students, here? So hydrogen from the primary amine and chlorine from the benzenesulphonyl chloride. So these two will be removed and this sulphonyl group will be directly attached to the nitrogen of the primary amine. So that is how we can get N-substituted sulfonamide. The resulting N-substituted sulfonamide, nitrogen will be still having hydrogen. So due to the presence of this hydrogen, the formed product will be having ester character. So when you add the resulting product in potassium hydroxide, an acid-base reaction occurs because potassium hydroxide is a base and N-substituted sulfonamide is having ester hydrogen. So as a result of this acid-base reaction, there will be formation of corresponding salt of this N-substituted sulfonamide. So these salts are soluble in nature. That is why there will be formation of clear solution in the test tube. Under such condition, when you add hydrochloric acid, then there will be exchange between protons of hydrochloric acid and potassium ions which are present in the salt. And that is how again hydrogens will be incorporated into the molecule and thus it finally results in the formation of N-substituted sulfonamide which we got in the first step. And this N-substituted sulfonamide is insoluble in nature. That means again there will be reappearance of the precipitation in the test tube if the given amine is a primary amine. Now let us consider the same reaction for secondary amines. So in case of secondary amines, let us consider this is the general structure of secondary amine where out of 3 hydrogens, 2 hydrogens of ammonia are replaced with alkyl moieties. So when secondary amine reacts with benzenesulphonyl chloride in the presence of alkali, it gives a N disubstituted sulfonamide. So what is happening here? Here also hydrogen from secondary amine and chlorine from benzenesulphonyl chloride will be removed. That means this benzenesulphonyl chloride via sulphonyl group, it gets attached to the nitrogen of the secondary amine. So this part is obtained from the benzenesulphonyl chloride reagent and this is the part which is obtained from the secondary amine. So this is how there will be formation of N disubstituted sulfonamide. So this compound is usually insoluble because as soon as the resulting product, if you add potassium hydroxide, it does not having any hydrogens. Okay. So when hydrogens are present in the resulting sulfonamide, it will be having ester property. So in that case, when you add potassium hydroxide, an acid-base reaction occurs and it gives corresponding salts which are clearly soluble, as we have observed in case of primary amine. But here, the resulting NN disubstituted sulfonamide, it does not possess any hydrogen. Because it does not possess any hydrogen, it does not having acidic character. So it does not dissolve in potassium hydroxide. It is because of that reason, the resulting product will be remained as insoluble product in the presence of potassium hydroxide. Now, under such condition, if you add mineral acid like hydrochloric acid also, because there is no potassium salt formation, there is no exchange of even hydrogens and potassium, and hence there is no reaction occurs with hydrochloric acid. So overall, if you see this reagent reaction with secondary amine, it results in the formation of an insoluble product in the test tube. Now, when it comes to tertiary amine, so here a general structure of tertiary amine is given. So you can see here all the hydrogens of ammonia are replaced with alkyl moieties. So this is an example structure for tertiary amine. Now, so once you recollect the reaction of benzenesulphonyl chloride with primary secondary amine, so what is happening there? One of the hydrogen from the amine and the chlorine from benzenesulphonyl chloride are removed, and that is how sulfonyl group will be attached to the nitrogen of the amine. But in case of tertiary amine, there is no hydrogen retained along with the nitrogen. Hence, there is no reaction between benzenesulphonyl chloride with the tertiary amine. Whatever the tertiary amine is there, that will be retained as insoluble product. Because the product is retained as insoluble product and does not possess any hydrogen, there is no reaction with potassium hydroxide. Now, in that condition, if you add mineral acid like hydrochloric acid, because tertiary amines are basic in nature and basic compounds are usually soluble in acids such as hydrochloric acid. Hence, when you add hydrochloric acid to the resulting product, there will be formation of corresponding amine salt, which is soluble in nature. And that is the reason as soon as we add hydrochloric acid, there will be formation of clear solution in the test tube. So overall, if you look at this particular reaction in case of tertiary amine does not react with benzenesulphonyl chloride. But the resulting product, whatever the tertiary amine as it is retained in the test tube, if you add hydrochloric acid, we get a clear solution in the test tube, which indicates that the amine is a tertiary amine. So this is how benzenesulphonyl chloride reacts differently with different amines. Now let us have a quick recap of this Hinsberg test. So in case of primary amine, as soon as we add benzenesulphonyl chloride, it reacts. So as a result of which, there will be formation of initially insoluble compound. But when you add potassium hydroxide to it, there will be acid-base reaction occurs, as a result of which there will be formation of soluble salts. So because of the formation of soluble salts, we get a clear solution in the test tube. Now, upon esterification, that is by adding hydrochloric acid, there will be reprecipitation of unsubstituted sulfonamide occurs. So we get an insoluble compound again in the test tube for primary amines. Now, when it comes to the secondary amines, they also reacts with benzenesulphonyl chloride, but there is no reaction with potassium hydroxide because there is no nitrogen left over in the finally resulting NN disubstituted sulfonamide product. But when you add hydrochloric acid, that is upon esterification, because the resulting product does not consist of any hydrogens or potassium by treatment with potassium hydroxide, there is no further acidification occurs. Hence, there is no change. That means overall for secondary amines, when you add all these reagents to the secondary amines, there will be finally appearance of only insoluble precipitation in the test tube. Now, when it comes to tertiary amines, because tertiary amine lacks hydrogens, benzenesulphonyl chloride does not react with tertiary amine. Hence, there is no reaction. Now, when you add potassium hydroxide also, there is no change in the tertiary amine. It will be retained as insoluble precipitation only. But when you add hydrochloric acid, immediately it reacts with tertiary amine and it gives a soluble salt. So, we get a clear solution in the test tube. So, tertiary amine, when you treat with all these compounds, we get a clear solution finally in the test tubes. So this is how reappearance of unsubstituted amide insoluble precipitate confirms the presence of primary amine, whereas insoluble precipitate upon reaction with benzenesulphonyl chloride confirms the presence of secondary amines, and formation of clear solution upon esterification confirms the presence of tertiary amine. So this is how the solubility profile of the resulting product in potassium hydroxide and further treatment with hydrochloric acid will decide whether the given amine belongs to primary amine, secondary amine or tertiary amine. So from this video, I hope you might have got Hinsberg test crystal clear. If this video is useful to you, then give it a like and subscribe my channel for more chemistry concepts. So in the next coming video, I'll be explaining about acid value determination. Again, one more important topic, examination point of view. So thanks for watching and stay tuned to my upcoming videos.